About 5 billion years ago, a star much larger than our own went supernova. In its death, it scattered its enriched guts across the universe, creating a cloud of dust and gas light years across. And in certain areas, this cloud of dust and gas clumped together and underwent nuclear fusion, forming the next generation of stars, such as our own. We are formed from the ashes of stars much bigger than our own. We are made of stardust. I'm Damon Scotting, and this is Astronomical.
$13.7 billion years ago, there was nothing. And then, the Big Bang. The Big Bang wasn't an explosion as per se. It was the expansion of time and space itself. In the beginning, it was infinitely dense and hot, but it expanded at the speed of light and cooled rapidly. Once temperatures were lower, the first particles burst into existence. They coalesced to form the first atom, hydrogen. For the first 200 million years, the universe was dark, until the very first star was born. This was the start of the stelliferous era, the age of starlight. Stars can come in many different sizes and colours. Depending on their mass, they typically take one of 3 different paths through life.
Now, low mass stars that have less than half the mass of our own sun are amongst the most common stars in the universe. These are the dwarfs. They can live up to trillions of years and spend most of their time in a stable condition, giving off small amounts of heat and light. When the universe dies, these will be the last stars to go.
A red dwarf is the smallest and coolest type of star in the main sequence phase. They're the most common type of star in the universe. Roughly 75% of the stars in our galaxy are red dwarfs. Just because they are small and give off little heat doesn't mean they don't have orbiting planets that are capable of supporting life. This is Proxima Centauri. It's a red dwarf and our nearest star. We recently discovered an exoplanet that orbits the star in just 11.2 days, 32 times quicker than the Earth orbits the Sun. The long lifespan of red dwarfs may make them ideal places for life to exist on. We've already discovered a number of exoplanets in orbit around red dwarfs. But being so close to the star leaves you overly exposed to any solar flares, which are very dangerous to life.
Now this is our own sun. It belongs to the next category of stars. Stars that have a mass between 0.5 to 8 solar masses. They will spend most of their life in the main sequence phase, before after 10 billion years they reach the end of it and swell into what's known as a red giant, burning off the last of the fuel remaining in their cores. Now this is a super giant. With more than 8 solar masses, these are the biggest stars in the universe. And they all abide by one simple law: live fast, die young. So after a few million years, when all their fuel is spent, these stars will go into a supernova. The large ones will collapse in themselves and form a neutron star, amongst the densest objects in the universe. But then the really large ones, the biggest stars the universe has to offer, will do something even stranger. Now these stars are so massive that they can't stop the gravitational collapse, meaning they form a void in space. These are black holes, amongst the strangest objects the universe has to offer.
Black holes are still today one of science's biggest curiosities. There must be millions of black holes in our galaxy alone that are invisible to the naked eye. For stars that don't quite collapse in on themselves and form a black hole, they produce a huge nebula, a cloud of dust and gas. In certain areas they clump together, condense and form stars. Stars such as our very own Sun. During the early stages of the solar system's formation, things were chaotic. It wasn't until after the first hundreds of millions of years that the debris slowly coalesced to form the 8 planets we know today, some of which are far larger than Earth.
So what is the biggest planet in our solar system? And which one's the smallest? Well, the smallest planet just so happens to also be the closest planet to the Sun, Mercury.
Being the closest planet to the Sun, Mercury feels the full force of its heat. But due to its scarcely thin atmosphere, its nights are well below freezing. It's the smallest of all planets, even smaller than each of the largest moons orbiting Jupiter and Saturn. Mercury completes an orbit around the Sun quicker than any other planet. It takes just 88 days to do so. It's because of this that Mercury is one of the hardest planets for us to see. Due to its tight orbit, it never strays too far from the Sun's glare. Several times a century, you can see Mercury appear to pass across the face of the Sun as it moves in front of our view here on Earth.
Then we have the red planet, Mars, which is about half our diameter.
It is similar in many ways to our own planet, but Mars is a cold, dry world. Home to the biggest volcano in the solar system and one of its deepest canyons. Mars is a place of diversity that has been long suspected to have once harboured life of some form. The dried riverbeds on its surface, along with its polar ice caps and similar seasons to Earth, give us strong evidence that it hasn't always been a desolate wasteland. Mars has 2 moons, Phobos and Deimos. Each are only several kilometres in diameter, and they are believed to be asteroids that were captured by a young Mars's gravity. A day on Mars is just a bit more than 24 hours, whilst its year is 687 Earth days, making it almost twice as long as here on Earth.
Followed by Venus. Venus is Earth's hot sister. It's only about 200 kilometres less in size.
Venus is similar in many ways to the Earth. They are roughly the same size and about the same distance from the Sun. But one thing they don't have in common is that whilst the surface of planet Earth is a lush paradise for life, Venus is a type of hell. Its atmosphere is almost entirely carbon dioxide, and the thick layers of clouds prevent anyone from seeing in or out. On December 15th, 1970, the Russians became the first to land a spacecraft on another planet. It gathered data for 50 minutes before succumbing to Venus's intense temperature and crushing surface pressure. In the early stages of the solar system, Venus may have looked similar to the Earth. However, as the Sun continued to grow, it boiled away the water on its surface and added water vapour to the atmosphere, which led to a runaway greenhouse effect, trapping the heat on Venus. Now the temperatures regularly exceed 400 degrees Celsius. Venus is unique as it's the only planet in the solar system that rotates clockwise. A day on Venus lasts longer than its entire year.
Then we have our planet, planet Earth, about 12,000 kilometres in diameter.
Earth is the largest of the 4 inner rocky planets, and as of right now, it is the only world known to support life. We are a blue planet covered in an abundance of liquid water. An average surface temperature of a mild 15 degrees as well as a number of other environmental factors, has led to the Earth being filled with life. Regardless of the climate, hot, cold, low, high, life thrives. By far the most unique planet in our solar system.
These are the gas giants, the smallest of which is Neptune. Now Neptune is about 49,000 kilometers in diameter. It's huge.
Neptune is the most distant planet from the Sun. Discovered in 1846, it has only recently completed a single orbit around the Sun, with one orbit taking the equivalent of 165 Earth years. Neptune gets its colour from the methane in its atmosphere. It absorbs the red light from the Sun but reflects the blue. The winds on the planet can reach 1,300 miles per hour, almost twice the speed of sound. And due to the intense pressure on the planet, it can lead to hydrogen and carbon forming diamonds that rain down.
And it's soon followed by Uranus, which is 51,000 kilometers in diameter. Uranus is special because as most planets rotate clockwise, Uranus rotates on its back.
Uranus is a gas giant. A collision with a planet-sized body has knocked it sideways, meaning each side of the planet now faces the Sun for 42 years at a time. It was only discovered by William Herschel in 1781 and named Georgium Sidus, in honour of King George III. However, it was later renamed by astronomers to Uranus, after the god of the skies.
Then we have the jewel of the solar system, Saturn. Now Saturn is about 128,000 kilometers in diameter, but if you account for the rings that go around the planet, it would technically be 250,000 kilometers. But we don't do this since there are actually satellites orbiting the planet. We only count the big bit in the middle. Now if I was to ask you to name a planet in our solar system other than the Earth, the first one that probably comes to mind is Saturn. Saturn is the gem of the solar system. No other planet is quite like it. The other gas giants also have ring systems going around them, but Saturn's are unique and beautiful.
Saturn's rings are made from billions of fragments of ice and rock. The rings extend beyond twice the diameter of Saturn, but on average they have a thickness of just 10 meters.
One of the more interesting things about Saturn is the density of the planet itself. Now all the gas giants are made up of the main gases such as nitrogen and methane, but Saturn is filled mainly with hydrogen and helium. And what this means is it's less dense than water. So if you had a body of water large enough to contain the planet and place Saturn in it, it would float.
Saturn was recently classed as having the most moons in the solar system. As of now, Saturn has 82 moons caught in its orbit, but that's likely to change as we discover even more.
Which then leaves us with the god of the planets, Jupiter. Now Jupiter is about 142,000 kilometers in diameter, which is about 12 times that of Earth. In terms of volume, Jupiter could swallow planet Earth 1,321 times. And you see this great red spot on the surface of this planet. It's a storm that's been raging on for almost 400 years. That could swallow the Earth 3 times whole. Our entire planet would be consumed by this storm 3 times.
If you were to take all of the mass from every other planet in the solar system and add it all up, Jupiter would still weigh 2.5 times more. It has the shortest day in the solar system, as well as 4 of its largest moons. These are the Galilean moons, each of which is a wonder in its own right. It has no solid surface, only an extremely thick atmosphere. If Jupiter had been made up of about 50 times more hydrogen, it's likely it would have become a star. Jupiter is very large, especially when compared to the Earth. but it is nothing when compared to the biggest body in our solar system, the Sun.
So just how big is the Earth compared to the Sun? Well, the Earth's about 12,000 kilometers in diameter, and the Sun is 1.4 million kilometers. That means you could fit about 1.3 million Earths inside just one Sun. So to put that in perspective, say the Earth was about this big, then the Sun would be the size of the London Eye.
The Sun is an enormous ball of hot, luminous gas. At its core, hydrogen atoms are converted into helium, releasing energy in the process that is felt here on Earth. It has existed for 4.6 billion years and will likely survive for another 5 billion. The Sun alone accounts for 99.8% of the entire solar system's mass. On the surface, temperatures are 5,500 degrees, whilst at the core they reach 15 million degrees. Despite the immensity of the Sun, it is just an average-sized star. There are plenty out there that are far, far bigger.
Now the Sun has been around for a very long time. 4.6 billion years is tremendous, especially when you compare it to the life of a human. We on average live for 80 years. So talking about something that lasts in the order of billions of years is very hard to comprehend. The age of the universe is 3 times older than our Sun. So, in order to make it easier to understand, this is the cosmic timeline. 13.7 meters representing 13.7 billion years of history, where every meter is a billion years and every centimeter is 10 million. Where do we start? The beginning of time and space itself, the Big Bang. However, it wouldn't be until 200 million years later that the first stars were born, and the universe was no longer in darkness. And it wouldn't be until 11 billion years ago that our own Milky Way galaxy would come into existence. Where are we? We're still not born yet. Our own Sun is a 2nd or 3rd generation star, which means it was formed from the ashes of 1, maybe 2 dead stars. This is the birth of our solar system. Now at this point in time, the universe is 9.2 billion years old, which means for us, relatively, we are very young compared to the age of the universe. In the early stages, things were chaotic. It wouldn't be until a billion years later that the first signs of life would form on our planet. Now there's much debate about how life formed. Some believe it came from an asteroid elsewhere in the galaxy that carried the ingredients for life. Others believe it started at the bottom of the oceans around hydrothermal vents. Regardless, the first real species of animal, the fish, weren't born until just 500 million years ago. 375 million years ago, Tiktaalik became the first creature to leave the oceans and venture onto the land, paving the way forward for many new species, including the amphibians, reptiles, dinosaurs, mammals, and birds. For the dinosaurs, their dominance was unchallenged and relentless for millions of years. Until 65 million years ago, disaster struck when an asteroid wiped out all of the non-avian dinosaurs, meaning the Earth was now up for grabs to those who were left on it. Amongst them were the mammals. They scurried around at night in fear of the dinosaurs, but now they saw their chance and they took it. They made the Earth their own. But in order to appreciate this small of a point in time, we're going to have to make our timeline bigger. How much bigger? Well, it now needs to be long enough to go around our entire planet.
On our current 13.7 metre timeline, each metre represents a billion years. But if we stretch it out so it's long enough to go around our entire planet, then on this new timeline, each metre represents just 342 years.
Now on this scale, we have now and 4,500 years ago. What happened 4,500 years ago? Well, we invented the alphabet, as well as the wheel. Soon after, Buddha was born, followed by Christ, the invention of zero, Muhammad, and then just over 500 years ago, the two sides of the planet became aware of each other as Christopher Columbus sailed the Atlantic. Copernicus told us that we weren't at the centre of our solar system, the sun was. Galileo discovered Jupiter's 4 largest moons. Newton released his Principia of Mathematica. At the start of the 20th century, the Wright brothers developed the first airplane. Ernest Rutherford discovered the atom. Edwin Hubble, the first galaxy. And perhaps most important of all, 50 years ago, man left footprints on another world for the first time. And by no means the last. Now when you scale things back to the previous timeline, showing all 13.7 billion years of the universe's history, we take up a very thin margin of it. In fact, the history of our entire civilization can be represented on this scale by the same thickness as 1/10 of a human hair. It's so small you can't even see it with the naked eye. But for me, the most interesting point in time is not on this timeline. It will be on the next one. The next 1/10 of the thickness of a human hair. Think of how far we've come in the past few thousand years, and just how much further we'll go in the next couple of thousand. Assuming we don't destroy ourselves, we will venture to new worlds. Perhaps in the next few thousand years, we'll answer some of the universe's biggest questions. Is it really 13.7 billion years old? And is this the only universe out there? What an astonishing question, asked by a species that was formed from the ashes of a dead star. I'm Damon Scotting, and this was Astronomical. Okay, 3, 2, 1. Oh, it's a massive crowd down there, yo! The smallest of the gas giants? It's okay. It's okay, here. Use it as a marker. As well as being the biggest planet in the solar system, has the most amount of moons. Okay, hang on, let me wait for traffic to stop. Okay. Oh, that bike. Let's try it again. Loud noises. These were Ganymede, Callisto. There's people behind me, giggling Asian girls. Sorry. Cheers. You know what? I think the blooper video is just going to be this. Larger than our own, went supernova. It scattered its enriched goods across the universe. Goods made of...